The first thing is to go ahead and make a range chart. Well, that you should be able to do, right? How to find the range column of the day. So all you have to do is just type in range, and range is equal to the highest, largest minus the smallest. And then drag and drop to find all the range values. All right, shouldn't be any problem there, right? Yes? No problem there. Then need to find the mean and standard deviation of these 4 columns. Okay? To do that, you go to data, and under data, you should see data analysis. If you've never used the data analysis before, you may not see it. If you have Apple, you may have a problem. You need to go figure out, just Google how to do data analysis on Excel in Apple. Somebody has explained it some. Now, if you have regular PC and you don't see this, anyone that not see this on regular PC, you all see that? Yes. Data analysis. You all okay with that? Yes. And then under that, if you click on data analysis, you'll see descriptive statistics. That's where you get your mean and standard deviation, variance, and all that. So double click on that, and then go ahead and highlight the 4 columns, including the headings. All right? Since I included the headings, you want to tape this or what?
So
what do you want to do?
I'm trying to tape it.
Well, that's a good idea. I want to tape it.
Okay, but I need like a good
What you need?
I say just put it in front of me.
Put it over here.
All right. Let me see this works.
Are you going to sell it?
No, not at all.
You can't sell it.
We're trying to make a video, bro. We send it to you.
You doing it?
Yeah.
Send it to me too, because can you do it on your cell phone? You have that much memory?
I have made sure I came prepared.
Cool, very good. Click on label in the first row. Anytime, label in the first row, and you can put your, the output, you can put it on descriptive stat. And click on summary statistics, and then there you go. Here comes your mean and standard deviation. That's what really we care for, the mean and standard deviation. The first 2 columns are not the standard error. Mean and standard deviation. These 2 columns are what you need, okay? The mean for range, the mean for largest, the mean for smallest, and this is the granddaddy of all of them, the X-bar, the average of all the averages. So you need this column for sure, you're going to use it, and plus you need the standard deviation column, okay? These 2 columns you need, okay? Actually, these 2 numbers are the most important ones, okay? So have that as your output. As you know, you have to copy and paste this stuff, and like this one, clean it up and copy it and bring it to the Word file and put it over here. There you go, all right? You're done with this part. Then part B, you need to find a standard deviation of individual bags. Now, there is no individual data given to you. All you got is the averages. So we need a standard deviation of the individual data. Well, the formula for sigma of averages, standard deviation averages, is standard deviation of original data divided by square root of n. Okay? Now this you already know and this you know. So the standard deviation of individual x's is unknown. So what you need to do, go back here, and the standard deviation is 1.355. Okay, so this is 1.355 is the square root of x divided by the square root of n. Okay, so standard deviation of individual data is 1.355 the square root of n. And what is n? 7. So this is the standard deviation that you need this later on when you're doing the CPK, the process capability, you need the standard deviation. All right? You okay? So calculate that and give me the standard deviation of original data. Okay, back here, part B. Now part C, the other day that is they support the claim by DCI that the average weight of bags is 4751. So we want to see if the average is, remember your statistic class? Probably not, right? Mean equal to 4751 versus the alternative of mean not equal 4751. Okay? So what you need to do is figure out your critical value here, which is at 5% is 1.96 and negative 1.96. Okay? And having that, your test statistic is x bar minus mean sigma over square root of n. Well, this you already have. That's sigma of x bar, you already have that. So what is x bar here? The average of the averages is, we had that. The average of the averages is x bar bar. What is here? 49.129, right? Minus the hypothesis of 4751 divided by a standard deviation that you already have, 1.355. And find the z value, all right? Whatever that is. And then compare it with this critical value. Remember statistics? So if this number falls here, you fail to reject. This is going to be a negative number, x bar. Oh. The hypothesis is 47. Okay? And based on that, decide whether to reject this or not. Okay?
So if in between those points you fail to
reject. That's right. So you want to see if it's 4751 or not. Okay? Parts D, construct a time series plot of all 4 variables and discuss your findings. Well, in the instructions, I told you to graph these 3 in one line chart and the range in one. So you don't want this time, so I'm going to hide it. Hide the time and then run this graph of the data, of the 3 data set. The average, lowest, and the highest. So highlight everything, insert a line chart. What is this now? Okay. So That's your line chart, but you cannot really see it very well. So you need to go change your scale on the y-axis, format axis, and make it from 40 to 50. That way you can see what's going on. 40 to 60. Now you can see it much better. See what I mean? So I like you to just have it between 40 to 50. So you can see the smallest is doing this, the average is the middle, and the largest. Okay, so that's one graph right there. You also need the graph of the R chart. Yes,
On that chart, you just have the average, smallest, and largest?
correct.
You want us to name it? Name that graph? Like,
Yeah,
You don't have the sample numbers in it either?
it's in there.
It's on the axis.
The first column takes the first column as the x-axis. When you highlight 4 of them, it takes the first column as your x-axis. So it's observations up to 72. You see that? The 72 observations.
And which one did you choose? Which line graph did you choose? The marker one or just the normal one? Because I'm not getting that. I'm not, it's something,
Did you hide this thing? Did you hide the day?
yes,
Do you have something like this?
yes.
Okay, let's do it. I'm gonna go step by step. I'm gonna highlight these 4 columns. All right. Then you go to insert over here. You can just do line. This time I'm gonna do line. Here we go. Wasn't that hard, was it?
Yeah.
Got it?
Thank you.
But how'd you get it 40 to 60?
Right, come here, right click here on this and format axis. Right click, move your mouse to the y axis, right click, format axis, and then here make it 40 to 60. And enter. There you go. Okay? All right, next, we're done with this, so I don't want this anymore. Okay, next part, also do the R chart, okay? Do the range. Range by itself. Get it? One line plot of the range by itself. Okay.
So we don't have to do largest, average, and smallest?
We did.
No, like, because
so you
we need to have one that has all 3 of them, and then we need to have a range one. That's it?
That's it.
Okay.
2 of them. Construct, export, and R charts. Graph and discuss your finding based on the control chart. Now here you have to go back and know how to calculate the upper and lower control limits. Okay? You should know that because you need that for the final exam too. So the formula for export chart, upper control limit is x bar plus A2R bar. Center line is x bar, lower control limit x bar minus A2R bar. Remember that? For R chart, upper control limit is D4R bar. Center line is R bar. Lower control limit is D3R bar. All right? All right? So, you need to find your control limit. I'm not going to tell you how to do that. If you don't know it, then you're in trouble. Okay? You need to be able to find it. So what do you need for that? You need what? X bar, do you have that?
Yes.
R bar, do you have that? We got that up here already. We got it up here. Here's the range, this is the mean. This is your R bar, right? And this is your X bar. All right? Yes?
Yes.
Yes, or I don't know. I want to hear you. Yes. X bar and R bar. You have it. A2. Where do you get the A2? From the chart. The chart. Okay, there's a chart in the table. If there's no chart, just Google it. Constants for control chart, you get it. Okay? Then find your upper and lower control limits. After you find it, okay, let's do, I'm gonna take this thing and copy it and put it over here. I don't want this thing. Let's hide it again. This is your average, right? This is your X bar, right? So you need your upper control limit and lower control limit. You calculate that somewhere else in the Excel or whatever. Let's say your upper control limit is 51.5. I'm just giving you an example of it, okay? Let's say it's 51.5. Okay, so upper control limit is gonna be the same all the way down. And let's say your lower control limit is 48.3. I'm just making up these numbers, okay? Don't use these numbers. All right, I'm just making them up. Okay, so I have upper and lower. You can do your center line too, okay, if you like. But after that, just highlight the columns and draw a line chart again. So insert the line chart. There you go. That's your X chart. So just go in there and type. And X bar chart. Okay. Got it? Yes?
Yes.
All right. Same thing with your, so take this thing, copy it, and bring it here, and paste it right after this. Put it over here, and explain it. You have to explain what this is telling you, okay? A graph without explanation, you're gonna lose point. So, is this in control or not? No, because you get a lot of observations out of control, all right? So, do the same thing for R chart, okay? So, what you need for R chart, again, you need your sample number, the range, and the upper and lower control limit of the range chart, just like that. All right? And explain. Now, if any of these charts, they work together, if one of them is out of control, the whole process is out of control. All right, so we're done with the step E.
You want us to name the Excel sheet?
Name what? These?
Uh-huh.
Yeah, because you're gonna send me both of them.
So like one name.
Part A, B, C, you can put it there. Just like what we did the first project. Usually, if you know, I come here and then if there's something doesn't make sense here, I'll go to your Excel. Sometimes some people just didn't give me the Word file, just give me Excel file. But send me both of them. The question is there any differences between the performance of the different shifts? All right, so what is every shift? Let's define the shift. From 6 to 1 actually, 8 observations. From 6 to 1 is the morning shift. From 1 to 9 is the afternoon, and from 10 to 5 is the night shift. So what you need to do is to come here and carve out you can just copy and take this somewhere else, and then the averages, the sample. Okay, just call this morning shift. All right. And then afternoon and night. Call it night shift, okay? Now, what's a morning shift? Morning shift, well, let me unhide this thing. Oh, where is it? There you go. So, 6 a.m., count 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. That's your morning shift data. So copy that and bring it here and paste value. Okay? You can also copy and paste your you don't need that sample number. All right, that's the first day morning shift, right? Then go get the second day morning shift, like 6 a.m. So go back to 6 a.m. again. 6, that's 1, 2, 3, 4, 5, 6, 7, 8. Copy and bring it over here. You follow what I'm doing. I'm carving out all the morning shifts. Remember what we're trying to do here? We want to see if there's a difference between the weights of the bags produced by different shifts. Okay? So, do it for the morning, do it for the afternoon, do it for the night shift. Alright? And then graph it. Graph it based on 1 through, okay, number, you're gonna get number 1 to all the way to 24. You only got 24 of them, right? If you get more or less, it's not right. So you got 24 data. So 24 data for morning shift, 24 data for afternoon, 24 data for night shift. All right? Then graph it. Morning, night shift, just like the graph you did for averages, and low and high graph it. So in this part, all you're doing is you want to see graphically, is there a difference between the shifts? Okay? So part F, take a look at the graph. See visually if there's a difference between the 3 shifts, okay? Are you with me?
Yeah.
Just graph it. So you're gonna get, you know, something like, I don't know, you're gonna get day shift, afternoon shift, and a morning shift, or night shift. You're gonna get something like that, different colors. So by looking at it, see if there's a difference, all right? That's one thing. Now, part G, so you just put the graph over here and explain the graph. Part G, we're gonna use some statistical technique to compare the 3 shifts. okay? So after you got your 3 columns of data, morning, afternoon, and night shift. Every column has how many observations? 24. 24, 24, 24 makes it 72 for 3 times 24. All right. Then you need to run what we call analysis of variance in. So what's analysis of variance? Analysis of variance is to check and see if the average of 3 or 4 groups are the same or different. Get it? So actually, probably you didn't have this, I don't know how far you covered in the statistics class, but a null hypothesis is the average of morning equal to afternoon equal to night versus at least 2 of them different, statistically different, all right? So you want to see if they're equal or at least 2 of them different. Got it? But that's what we care. You're going to see if you have a graph that your morning weights are less. But the question is it statistically significantly less? So what do you have to do to run an ANOVA? Here you go. The 3 columns you got, morning, afternoon, night shift, I'm gonna assume these are my 3 columns. Average, small and large, okay? But that's not what you're gonna do. You're gonna run it on these 3 shifts, okay? So this is what you do. Go to data, to do analysis of variance, go to data, data analysis, and then your first option there is ANOVA single factor. All right, click on it. Okay, now highlight your 3 columns of morning, afternoon, and night shift, all right? Well, I don't have that, so I'm gonna highlight these 3. It's the same idea, all right? This is not what you have to do, but here you go. I highlighted the 3 columns. Think of it as your 3 columns of morning, afternoon, and night shift. Click on label in the first row and call it ANOVA ANOVA table list. All right? Okay, well, there we go. So instead of average, smallest, and the largest, guess what you're going to read here, yours? Morning, afternoon, night.
So you have to have like only morning, afternoon, night, right?
That's all you got.
With the numbers or without the numbers?
What do you mean with the numbers?
She needs
See, with 1, 2, 24, just the.
No, you don't need the numbers. Just the 3 data set. That's it. All right. The most important thing for you is the p-value. Remember p-value? The lower the p-value, the more evidence you have against the null. So here, is that a low number?
Yeah.
Why this is a low number?
Because the different averages are different.
No, why this number is a low number?
Because it's a negative exponent.
It's a negative exponent. You heard her?
Yes.
Is that number less than 5%?
Yes.
Yes. Don't make that mistake on the test. It's a low number. So that tells you reject the null, accept the alternative. Accept the alternative means what? At least 2 of these shifts are different. Got it? And that's it. So all we care about is your critical F value is this. This is your actual F in the data, but we just care about the p-value, all right? So there's your p-value, very small, so you reject the null, accept the alternative, and conclude that, yes, statistically they are different, all right? Very good. Back toward, we did that. Now, I've given you the tolerance limit, and I'm asking you to find the CPK. Now this is you can do that by hand, all right? So make sure you know CPK. CPK is what? CPK is minimum of upper specification limit minus x bar over 3 sigma and X bar minus lower specification limit over 3 sigma. All right? So, what is upper specification limit for this problem?
52.5.
Very good. What is your X bar?
49.13.
That's your X bar, okay? That's your X bar. 3, what? Where is sigma? Where'd you get that? Step what?
A.
Step 2. So 1 or 2?
I think it's one.
It's 1? No, 2. The second one.
The second one is given is 2, but the first one is 1.35.
It's 2. The standard deviation of individual data. That's what it is. So that's part 2. The number you get in part B. Remember? Part B. That comes from part B. So, everything is given. Find a CPK. What's the magic number for acceptable?
1.33.
1.33. So if it's greater than, less than 1.3, no good. Process not capable. You have to explain that. Everything you have to explain. Okay? Explain what it indicates and if the process is capable. So I want answer here. You're all gonna get the right numbers, but you have to explain these. All right. So that's straightforward right there. Number part F. Now we're gonna improve the process. I'm gonna adjust the average, the X bar to 50, and we're gonna reduce the standard deviation to 0.6. Now what's the new CPK? So what happened? The specification limit stays the same. X bar, the average instead of being 49, now let's say we can adjust it to 50, all right? And the standard deviation, let's say we reduce it to 0.6. Got it? Are you with me?
Yeah.
Recalculate the CPK. All right, so the next part is X bar becomes 50, sigma becomes 0.6. And recalculate the CPK. Now, is this process better or not? So now what if I want to have a control chart for the future monitoring. I'm giving you the X bar. That's actually, this is X bar of 50.1, R bar of 2 pounds, and N is 5. Do you know how to calculate upper and lower control limits of X bar and R chart?
Yes.
This is actually X bar, okay? All right? So I'm giving you X bar. Well, actually, this is. The average is 50.1 and R bar is, this is your grand average, 50.1, and R bar is 2 pounds. Now here's a new N for you. I changed the N. That makes a difference on what?
The A2, A3.
Very good, very good. That makes a difference on A2, D3, and D4. And everything else is the same, all right? So, now go back and see what is this project is all about. It's all about trying to improve this process and make recommendation to the management. So I want you to give me like a small paragraph. Don't write me 3 pages. I can't read, I don't have time, all right? Just give me half a, 5, 6, 7 lines of, okay, this is what's going on. The process was actually, who was to blame? The morning, afternoon, night shift, okay? What's going on, if the process was in control or not, and now, what is the new process and what is your recommendation? So all of this is provide you a hint of what to recommend, all right? Any question? This thing is due Sunday night, all right? Don't wait till Sunday at 10 o'clock because your computer breaks on you.
Oh, that's weird.
It's
I thought you
11:59,
moved to a Monday evening.
No, I didn't. 7?
I thought,
I'm not that old yet. All right.
Is it due Sunday 11:59, right?
That's right.
Um,
Don't wait. Just do it. Do it right now.
Can you explain part A one more time, just one time?
Part A.
Yeah.
Yes.
Part A was just average these to find your range. One other thing you can do, you can come down here. Okay, I can say a mean and a standard deviation. I don't even have to do all of that. So just put equal to the average of these numbers. I think you're gonna automatically pick it. Okay, so the averages are.
I thought you wanted us to put that chart there.
You can. You
How do you do that?
don't need it. But the standard deviation is equal to the standard deviation of a standard deviation of these numbers.
And you want us to do the one of each bag down there too, right?
The what?
The standard deviation of each bag?
Each bag?
Yeah.
What each bag?
Small, large.
No. Well,
Well, that's in B. I'm sorry. That's B. That's not A.
so here's the mean of all of them. This is your R bar, is that correct? Your R bar is 3.7?
Yes.
So we can keep it simple like that, and don't need a big
Chart.
device?
Yes.
Gotcha.
All I ask for is the mean and standard deviation. The rest of it is useless. Okay? So you can just give me this, and that's enough for each of them. Okay?
And can we keep C also? What do you see?
I wrote it over there somewhere. That's a hypothesis testing.
So C and what is it, F? They're kind of the same? No, not F. Sorry.
No.
G. C and G.
C, well, G, you're comparing 3 shifts.
Okay.
In C, you're comparing the average of all of them to see if it's 47 or not. Okay?
What are you comparing the average to though?
47.5. They're claiming
Oh, okay.
47.5. Okay?
I missed C, I mean G. I don't think I got what we're supposed to do on that one. Is that the chart one, or we?
Find your morning, all your afternoon, all your night shift. And then do data analysis one way, ANOVA. This is it. Okay, let's say this is your shifts, all right? You go to data analysis, ANOVA, and highlight these. Put a check mark. Pay attention. You have to highlight the heading. After you highlight the heading, you have to tell Excel the first thing it sees is a label. And then that's it. You're gonna get your odds. And the only thing you care about really is the p-value. The p-value is very low. That tells you the shifts are different. All right?
So,
But that's F, right?
G.
so in C, our null hypothesis would be average mean equals 47.5.
Yes.
Okay. And then the mean hypothesis would be they're different.
H, G.
H,
Yeah,
A.
G.
On C. On
C, yeah.
C, it have the null hypothesis would be average of the mean equals average of the mean equals 4.7, and then the hypothesis HA would be they're different.
They're equal. The average of the different shifts are equal versus they're not. All right. So I think you all got a good handle on this. I've already written the test. For those online students, very important, I've already posted the whole test. Work on it. Okay? Problems are pretty much everything is the same as the old tests. Alright? So review the old test, plus you need to be able to analyze multiple regression output just like what we did in the regression project. You got it? I'm testing and see if you know how to analyze multiple regression output. Okay? I give you that's one problem you haven't seen on the test, but you have seen it in the project. Okay? 2.5 hours. Most of the online are doing it at the testing center, right? Some of you.
We're allowed to take a sheet of, right?
You can have formula sheet, yes. 1 page, back and forth formula sheet.
Kind of question too, right?
Of course.
And so most likely the 3 tests that you upload, you just have to go over those.
If you know how to do them, you're in good shape.
How many questions?
8 problem, 10 multiple choice. Multiple choice is 20, 8 problem is 8 or 9. About 80 points problems and 20 points multiple choice. And multiple choice are also just like.
Wait, but we're putting it out on a Scantron?
You need a Scantron.
Okay, so it's the whole test is multiple choice?
No.
No.
You don't want the.
So we're writing on the test?
Yes.
Oh, okay.
Only 10 multiple choice, those are on Scantron. The rest of it is.
Okay.
Any other question? If you haven't done the class evaluation, do it. Class evaluation you have to do.
You get the, you put it, right?
Yes. I've already figured out how much you have earned up to now. Okay, in terms of points, if you go to Gradebook, you can see what you have already earned. Then there's 35% that's coming your way. Plus, I will replace the final exam if you do better with the lowest grade.
I heard everyone who has a average is exempt from the exam.
You need to get your final exam.
You did tell us that last class.
Yeah.
Like what?
You said whoever already has an A, they get exempt from the
If you
exam.
come back in 20 years when I'm older, then I forgot. I said, oh yeah, I forgot. I mean, not yet. You never exempt the final exam.
On the online test, for one of the problems, I was only off by a couple of points, but I don't know.
That's the problem with the multiple choice. Multiple choice, you either get it or don't get it.
What was it, multiple choices where we filled it in, but I was only like off by 24 points. Are we done? Well, I mean, the answer was right, but the computer was either wrong and I didn't right. So is it wrong? I mean, it's right.
Well, email me, I'll pick it.
Okay.
Guys, there's one.